So I'm sure you've all seen how these work. If I drop one of these, you get this nice periodic motion where all of the energy is transferred from this one to this one. Almost it seems instantaneously. I've heard a lot of different explanations for how this works, but personally, a lot of them don't satisfy me very much, so hopefully I can satisfy you today. These are the carts that I use in my classroom. I have these repelling magnets, so yeah. So I want to show you what happens if I send one cart headed towards the other. If I start this cart at rest and then send this one into it, what happened there was originally this one was at rest and this one was moving. After the collision, this one was at rest and this one was moving at the same speed that this one was moving. This is just because they have the same mass as each other and because we have what's called an elastic collision, or a collision where the objects bounce off of each other and don't really lose any of their energy in the process. The collision between these Newton balls, every time one of the Newton balls hits one of the other ones, there's a bounce that happens. In fact, if I drop these outer two, they'll just bounce and bounce forever. In fact, if I move these three aside so they're sort of out of the system, you can see what happens if I only had two balls in the system. Here, they trade their speeds. This one will be moving while the other one will be still, and then this one will be moving while the other one will be still. If I have three in this system, every time this one falls, it imparts its energy into this one, since this one has the same mass. This one would then start going at the same speed as this one went at. However, it's so close to this next ball that it takes 0 time for it to reach it. If we could have some spacing between them, we would see that there would be a moment where this one had the same speed as this one started with before it collided with this one and went to rest. Since they're already touching each other though, it takes 0 time for that collision to happen. So this one strikes, and the next one gets going. It looks like these three middle balls aren't doing anything, but really, they're having these split-second collisions with the other balls and passing on that momentum and energy. Why doesn't the energy ever get transferred to two balls instead of one? Why don't they split it? I can force this to happen. This time, I dropped one, and two did get going. However, it forced there to be some loss in this energy, and the motion dies out pretty quickly. Hopefully this sheds a little bit of light on how this Newton cradle works. Maybe you've been seeing it your whole life, but maybe up to this point it's been a little bit of a black box. I'm curious if you've seen what happens if I instead drop two. What happens if I drop three? And if I want to drop four, the pattern's still holding. I'm still getting 4 on this side, I'm still getting 4 on this side. It's just those middle 3 have to keep moving to keep the pattern going. And of course, if I drop all 5, pattern holds, it's just not very impressive. If you do have any questions, I would love for you to leave me a comment. If you want to see more demo videos like this, feel free to subscribe to my channel. Next week, I'm actually going to be showing a projectile motion problem. It's more for my students. If you want to check it out, you can have a look. I will see you then.